Hi, Road Pounder here. I've been watching a lot of YouTube videos about guys who have converted their Harbor Freight motorcycle table lift from the standard hydraulic jack that it comes with to an air over hydraulic system so they can pump it up with compressed air. I bought mine in 2008 and it had the air over hydraulic system in it. But after about 13 years of very frequent use, the hydraulics were working okay, but the pneumatics started giving out. I had been toying with the idea of converting it to a hydraulic cylinder similar to what's used on a log splitter, and I spent about a year searching around the internet and through junkyards trying to find the components to piece something together that I thought would work. I eventually ran across a hydraulic pump unit used for an automotive lift that I thought would work, and I started putting things together, and what I came up with seems to work pretty well. This video is about what I did to the lift, the various modifications I did to it with the hydraulics, and a few other modifications that I did to it. So I hope you watch and enjoy. This is the air over hydraulic jack that came on the unit. As I say, it worked well for probably about 12 years until the pneumatic portion of it started giving out. And what I found when I tore it apart, I found there was a machining chip that had not been cleaned out during the manufacturing process, and it worked its way in and was holding a check valve open. I fixed that, got it back together, got it all dialed in, and it worked for about another year. Then it gave out again, and I started manually jacking it up. As I said, toying with the idea of converting it to a hydraulic cylinder, I moved over to this cylinder. This is a 2-inch cylinder with a 6-inch stroke. The stroke on the original jack was only 4 inches, so I had plenty of room to play with. What I found out was that the 2-inch cylinder would probably only give me about enough power to lift about a 900-pound bike, and it was pretty well maxed out. So I moved to a 2.5-inch cylinder. That gave me plenty of force to lift a 1,000-pound bike. The biggest bike I've ever had on this lift was about 960 pounds, and it didn't have any trouble lifting that. With the 2-inch cylinder and that 960-pound bike, it'd blow the circuit breaker about a third of the way up, unless my buddy was on the front helping it. Then it could get it all the way up. So I went with the 2.5-inch cylinder, and that seemed to do the trick. This is the hydraulic pump unit that I bought. I found it online. These come in 2 variations, well actually 3. You can get them in 12 volt, 110 volt, or 220. I don't have 220 in my shop, so I opted for the 110 volt, and it seems to be doing the job just fine. The problem is it puts out 2 gallons an hour, I'm sorry, 2 gallons a minute, and I'm only moving about 10 ounces of fluid. And what happened was when I hooked it all up, put my bike on it, hit the button, it turned my lift into a catapult. It lifted the bike from all the way down to all the way up in less than 2 seconds, so I had to slow it down. And what I did is I made a restrictor that I put in the hydraulic line to slow the amount of fluid going into the cylinder. I had to slow the rate down so it wasn't pumping in so fast. And anything that it couldn't pump through that restriction, the pressure relief valve in the pump unit would just dump it back into the tank. Here's the hydraulic cylinder that I put on it. The other one that I showed you, the 2.5-inch cylinder, is going to go on my other lift. Now the rod for the cylinder is considerably smaller than the cup that it's got to go in, so what I had to do was machine up a collar that would thread on the end of the rod for the cylinder and fit into the cup. The mounting system, that is a 4-inch square steel tube with a 1/4-inch wall, and what I did was I cut it to length. The post I made out of 3 pieces of 5/16 by 2-inch bar stock, sandwiched together and welded, and then I put some bracing in on the side just to give it a little bit bigger footprint and a little more strength. Now the one mistake I did make is when I chose the stock for the cross member here, I should have gone with 3-inch instead of 4-inch. 3-inch would have been plenty strong, and the problem I have is I welded this so it was centered vertically on the frame, and it sticks up a little bit, and the lift table actually came down and rested on the cross member instead of on the frame, and with the heavy end being forward, it would tip the lift forward, and that elevated the backside and made the ramp just that much steeper. So what I did is I welded in a couple stops on each stop on each side to hold the front end of the lift up a little bit and keep the back end down. The lift unit has this green button here, that is the go switch, and this lever here is to let it down. It goes up by power, comes down by gravity. I also installed on this side, right down in here, you can see the back side of another go switch. That switch is on a pedal on the other side so that it can lift the bike from either side. If I'm over on this side of the bike, I can raise it by just stepping on a pedal switch. Right here is the pedal switch. I just kick that with my toe and it engages the motor and lifts the bike up. Over here I've installed a stop switch, which is a normally closed switch. So when the switch is not pressed, it is in the on position. When the left front lift arm comes up, it contacts the switch, turns the circuit off, and stops the lift from moving, keeping it from overextending. Another modification I did to this lift was for the shaft that this V-plate pivots on. It had a bolt right here to keep it centered. That bolt broke off twice. Having had enough of that, because every time I worked on this thing, I'd tip it on its side and that shaft would slide out. What I did was I drilled and tapped the end, bolted a fender washer on each end just to keep it in place. The fender washer is a little bit bigger than the hole, so it keeps everything in place. One design flaw that this lift has that I suspect has been carried on to other versions of it is that they didn't provide for any lubrication for the bushings where the upper end of the lift arms attached to the table. I took out the old worn bushings because they were creaking quite badly, and I machined up some new ones with a shoulder on them so that they would just fit in between across the lower frame rail. Then I took some longer bolts, drilled them for grease passages, and installed zerk fittings on the ends. Then I double nutted them on the inside just so I could adjust the slack and make sure that it didn't bind when I tightened it down. The brass piece on the head with the zerk fitting, that was kind of to fix up my mistake, because I had drilled the holes for the zerk fittings too big, so I've made that just get by. I would have normally just drilled and tapped the head of the bolt and inserted the zerk fitting straight into the head of the bolt, but I didn't feel like going down and getting new bolts to replace the ones that I messed up. When I made the restrictor to slow down the flow of the fluid into the cylinder, I originally put it in right here, but that was a mistake in that what would happen is it would immediately overload the system and blow the circuit breaker. Figuring out what I needed to do, I found that the hose had a little bit of give to it when it was pumping up. So I put the restrictor down in that elbow fitting down here, and what that did is it bought the motor enough time to spool up, and then it would pump the fluid into the cylinder and raise it. Now when I first tried this without the restrictor, it took less than 2 seconds to raise the bike all the way. Once I put the restrictor in, it slowed it down to about 8 seconds to lift the bike all the way. The problem with the quick lift is when it got all the way up, the inertia would jerk the whole lift assembly and bike. It would jerk it back across the floor about 4 inches every time I lifted it. So I had to slow it down so it wouldn't build up all that inertia and the lift would stay in place. This is the restrictor that I made to go into the fitting on the hydraulic cylinder. What I did was to run a 3/8 27 pipe tap in far enough that I could screw the brass restrictor in far enough that it'd be flush. To make the restrictor, I carved it up on a lathe, threaded it at 27 threads per inch, and drilled a 25 thousandths hole in the center of it. I had to restrict it down to 25 thousandths to slow the lift down enough to keep it in place when I raised it. Yeah, let's see this thing in action. And there you have it. It's been working well for me, so that's what I did with mine. Okay, that's what I've done to this lift, and I intend to do the same thing to the other one. As I do, I'll make videos showing the progress of the modifications as I go through them. I hope you enjoyed this video. Thanks for watching, and feel free to leave comments in the comment section. Thanks again.